Studying entanglement is paramount to understanding and developing a quantum computer. At the IQC, I've managed to invent a device that makes it easier to experiment with this phenomenon. This whole idea started originally as an idea at the final ends of my PhD thesis, which I did here at the University of Waterloo.
Photon entanglement is very important for several reasons. First of all, it's a very fundamental feature of quantum mechanics. It's essentially at the core of those mysteries which we don't understand actually, and it's very exciting from a fundamental aspect. But it's also very important for applications. It can be used in quantum computing, for example. It's an important tool. It's useful for secure communications by doing quantum cryptography. It could even be useful one day for metrology, improving measurements, or telescopes. Rolf's device is very interesting because it would enable us to experiments and use entangled photons in our experiments and setups, but without having to build our individual sources, which are costly and big to set up. However, because this device from Rolf is small and compact and robust, it would just simplify the life in our research.
And so once we have these two photons, we think we can entangle them. But the trick here is to interfere them later on, to remove information from the system and sort of confuse nature. And that is a difficult thing to do. And the reason why it's difficult is it often involves an interferometer. And interferometers are insanely difficult to create. I take that last component, the interference, and I make that completely user-friendly. In other words, no one has to create an interferometer anymore in the lab in the methods that they used to do. So the interference will occur in a very compact setting. It brings down the cost of the effective cost of obtaining a device like that. And what that does is it makes this type of device or this type of experiment or even this type of work more accessible. I think there's a lot of value in people who aren't necessarily experts in quantum information science, who might have an idea as to how to use this device, or who will be able to play with it and look at the results and contribute. The community's been very supportive in Waterloo. Industry's been very supportive, and that just makes a perfect it makes the perfect storm to get things going. I mean, you can't just do it by yourself.
So it can be widely used for, let's say, visiting students or even school classes, visiting and taking a look at it. It's also very good for IQC to work on such a device because one of the mandates of IQC is also to advance the quantum science research and quantum science as a whole.
We'll accelerate the path to quantum computing by having more and more of these devices being available to everybody.